Hello all. In the last session we have covered some basic concepts of word embeddings. Today in this session we would cover word and document embeddings along with building blocks of NLP, how do we process natural language, and then we will also look into tokenization, stemming and lemmatization, some of the building blocks of NLP. So to start with, we have already discussed about word embeddings. Let us quickly have recap of that. So we have seen that word embedding is a real valued vector representation of the word, that is a given word has, we can't represent a given word with single dimension, hence we divide that particular word with 3 elements within an array, and then if you do that particular thing, you can plot them as points in the 3D space. As you can see, we have taken 3 words here, cat, dog and pizza. So I have divided these 3 words into an array of 3 elements each, such that I can plot them in the 3D array, and I can see that dog and cat are belonging to the same category, hence they are placed close to each other. So here I call dog and cat as semantically related words, right? This is what we have seen in the last class, and we have also seen why are word embeddings important. There are 2 points that you have to understand when we talk about this. First thing is, word embeddings are important because we develop we process natural language processing using natural language during neural networks. Okay, so there are 2 complications that comes into picture when we talk about neural networks. First thing is, neural networks are pure mathematical computation models that can deal only with numbers. Okay, so they can't do symbolic operations such as when I want to concatenate 2 strings, or when I want to do some operations within the strings, that is not possible for neural networks. That is first point. And when I talk about second point, everything in NLP is available in words or labels, or when I say sentence. Okay, so everything here is available in this, and all these are discrete values. Okay, so when you have these discrete values, when you can't perform symbolic operations using neural networks, then we use word embeddings. Okay, so in order to bridge gap between these 2 different concepts, we will be using word embeddings. Okay, so as you can see, this is a figure which will give you a clear picture or overview about how do we use word embeddings for an NLP applications. Okay, so when you have large text data, we convert that text data into word embeddings, that is words. Okay, now we give these particular word embeddings as an input to NLP model. Based on the training data, we get the prediction. Okay, so the first and foremost thing that we do is we take the large text data as input and convert that particular large text data into words or word embeddings. Okay, now word embeddings, just like any other neural networks, they can be trained because they are simply collection of parameters. Okay, now embeddings are used with our NLP model in 3 important scenarios. Let us discuss those 3 scenarios. So here are the 3 scenarios which are mentioned. Okay, the first case, when I talk about the first one, we say train word embeddings and your model at the same time using the train set for your task. Okay, so we use these word embeddings in 3 different scenarios. Okay, whenever you're developing an NLP model, you can use word embeddings in 3 different scenarios. Okay, let us have a quick look about those scenarios. First thing is, you can train word embeddings and your model at the same time. Okay, so you can generate the word embeddings and develop your model at the same time. As your word embeddings are generated, your model will process them. Second thing, or in the second scenario, first we obtain all the word embeddings independently using the large data set, and alternatively we also obtain pre-trained word embeddings from somewhere else. Okay, depending upon the context or the text that we use, we can obtain our pre-word embeddings from somewhere else. Okay, after you do this task, we then initialize our model using the pre-trained word embeddings and train our model. Okay, and the last scenario, it is same like second, except you fixed your word embeddings. Instead of obtaining it from somewhere else and generating for your thing, we fix our word embeddings. Okay, while you train your model. Okay, these are 3 scenarios we use for developing our NLP model. Okay, now when we talk about the next thing, this is what we have discussed in the earlier classes, earlier sessions. Now when we talk about word embeddings. Okay, we initially talk about the building blocks of the language. So there are three important building blocks of natural language processing. One is called characters, words and phrases. Of course all of us know these are English terminologies. Okay, so as told you earlier, NLP is all about linguistic along with AI. Okay, so let us have quick recap on quick understanding about what are characters, words and phrases. Okay, so generally character is the smallest unit of a writing system. As we know, in English language we have A, B till Z as characters. Okay, now sometimes characters does not necessarily carry some meaning by themselves. Okay, unlike Chinese language. Okay, in Chinese language every character has some meaning. Okay, so depending on different languages, character either holds some meaning or character may not hold some meaning, but character can be used for forming meaningful words. Okay, so a typical character in many languages can be represented by single unique code. Okay, for example A to Z. Okay, individual words we use. Okay, many languages use a combination of more than unique code to represent a single character. Okay, next, as we can see, A, B, Q are the characters. Using these characters, we form some words. Okay. Now, when we talk about characters, after characters, we step into discussing about words, tokens, morphemes, and phrases. Let us look into each of this. When I talk about word is the smallest unit in a language that carries some meaning. Okay, so using characters we form a meaningful word. Okay, now in English apple, banana, zebra are some meaningful words which represents apple and banana as fruit, zebra is an animal. Okay, so in most written languages we use these words as alphabetic scripts. Okay, so we use punctuation marks to separate words when we talk about a sentence. Okay, so in languages there are some languages like Chinese, Japanese and Thai language where words are explicitly delimited by spaces. Okay, so directly we cannot predict the meaning from that particular word, but we require some pre-processing which is called as word segmentation to identify the meaning of that particular word. Okay, now when you talk about token. Okay, so here often we get confused with words and tokens. Okay, they're interchangeably used, but there's slight difference between a word and a token. Okay, in NLP often we use the word term token instead of words, we use the term token. Now let us see and understand what is the difference between word and a token. Okay, now when you look into a string of contagious characters that play a certain role in a written language, for example, let me take the same example, apple, banana and zebra. Okay, now these are called as tokens because I have included punctuation marks such as exclamatory mark. Okay, so these can be considered as tokens but not words. Okay, so when I write a sentence wherein I use some punctuation marks, okay, even they are considered as tokens but they are not considered as word. Okay, for example, let me say I am Asha. Okay, and then put an exclamatory mark there. Okay, now in this particular sentence I am Asha are the three words. Okay, but when I talk about tokens I have four tokens wherein I also include my exclamation mark. Okay, now words and tokens are often interchangeably used in NLP. In fact, when you see word in NLP text, okay, it often means token. Okay, tokens are nothing but the extra labels that we use in the sentence apart from the words also. Okay, so basically tokens are the output of a process called tokenization. So we have this process called tokenization which will give you all the tokens when you give input as a sentence. Next, another term that we often used is morphemes. Okay, so morpheme is the smallest unit of meaning in a language. So here also it is similar to word. Okay, but typically a word contains one or more morphemes. For example, when we talk about apples, we consider this as one word. okay. But here when I talk about morpheme, I say apples has two morphemes, apple and s, okay. So a typical word consists of one or more morphemes. For example, apple is a word and also a morpheme. Apples, here when you look at this plural form, apples is a word comprised of two morphemes, apples and s, okay, which is the plural form of apple. So English contains many other morphemes like acting, act and ing, okay, acting, ly, ness and un, okay. So the process of identifying morphemes in a word or sentence is called as morphological analysis, okay. Just remember these terms: tokenization for identifying tokens, morphemes to identify morphemes, we go for morphological analysis, okay. And then we talk about phrase, okay. So phrase is a group of words that play a certain grammatical role, okay. For example, the quick brown fox is a noun phrase, whereas jumps over the lazy dog is a verb phrase, okay. So group of words that behaves like a noun or a verb, okay. Next we talk about engrams, the most important terminology that we often come across when you deal with the NLP is engrams, okay. So when I talk about this engrams, engrams are nothing but the contagious sequence of one or more occurrence of linguistic units such as characters or words, okay. So when I talk about it has only one word, quick brown, two words, brown fox jumps, three words. When I talk about words, when I talk about characters, B one character, BR two characters, row three characters. So here N is 1, N is 2, N is 3. When I talk about N here in characters, N is 1, N is 2 and N is 3. Okay. So all engrams of size 1, we call it as n is equal to 1, they are called as unigrams. If n is equal to 2 or n is equal to 3, we call them as bigrams and trigrams respectively. So grams are nothing but contagious sequence of one or more occurrence of linguistic units. Okay, this is about what are phrases, what are words, tokens, morphemes and phrases. Okay, now let us talk about some important steps where these linguistic units are processed in NLP. Okay, so if I want to process the sentence, okay, I process this particular sentence with respect to words, tokens, morphemes or phrases using three important steps. Okay, so those three steps are tokenization, stemming and lemmatization. Okay, so let us talk about tokenization first. Tokenization is simply the process of splitting the given input into smaller units. Okay, so if I have a sentence, I am Asha, I want to divide this sentence into words. So I say I is different, I am Asha, three words in this sentence. Okay, suppose I say I am Asha, I am teaching NLP. So when I talk about sentence tokenization, I say I have two sentences. I am Asha is one sentence, I am teaching NLP is the second sentence. So tokenization is all about splitting the given sentence into parts, okay, smaller units. So we have two types of tokenizations, one is called as word tokenization and the second one is called as sentence tokenization. Word tokenization splits a sentence into tokens, sentence tokenization splits the sentence into the given input text into sentences. Okay, so here words, here it is sentences. Okay, so this is an example, this is a sample. Okay, when I talk about word sentence, okay, so this is one word, is one word, a is one word, sample. So I have four words in this particular sentence, word tokenization. Okay, and the second concept of processing the text in NLP is stemming. Okay, so stemming is the process of identifying word stems. Okay, for example, if we talk about apples, okay, when I talk about the word apples, apple is the word stem. Okay, when I talk about the word meats, meat is the word stem, the meaning, the removing the suffix. Okay, so the word that we get removing the suffix is called as your stemming word. Okay, so it is often a part that remains unchanged after inflection. So basically stemming is all about normalizing words to something closer to their original form. We use this process of stemming in most of the applications of NLP. Okay, the most popular stemming algorithm is called as Porter stemming algorithm, which we will discuss when we go for hands-on experiments. Next, lemmatization. Lemmatization, or often called as lemma, is the original form of a word that we get in a word. Okay, so when I have this word meetings, okay, meeting is the plural noun or the lemma of the word meetings. Okay, when I say the lemma of met, it is meet. Okay, so lemmatization will give you the meaningful word in that particular sentence, whereas stemming will only remove the suffixes. Okay, so if you want meaningful word to be generated, we go for lemmatization. Okay, as you can see, change, changing, changes, changed, changer. So in stemming, only the suffix will be removed. Okay, when you talk about lemmatization, the meaningful word called change will be generated. Okay, so here these are the differences. As you can see, achieve, achieving, the meaningless word just by removing the suffix is obtained by stemming, whereas in lemmatization we get the proper word, which is achieve. Okay, so stemming is used for reducing words to a stem that may be meaningful or meaningless, operates on a single word without knowledge of the context, but it is simple and faster. When you talk about lemmatization, it reduces the infected words into meaningful lemma. It can leverage context into consideration. It is more accurate but slower in process. Okay, so this is all about tokenization, stemming, lemmatization, and the building blocks of NLP, which are characters, words, phrases, morphemes, etc. Thank you so much.